Hello everyone and welcome back to the garage. In this video we're going to do something a little bit different. We are going to be restoring two Texas Instruments calculators from the early 1970s. Now I'm not really a calculator guy, but I do know a lot of other people on YouTube who are. This is something I just happen to be at the right place at the right time. So I have these two broken Texas Instruments calculators that we are going to be restoring. So let's get started. So the other day I was at one of the thrift stores not too far from my house, and I was looking through the electronics they had there, and buried in one of the bins I found this. And I knew that this was a Texas Instruments calculator because it's a calculator sized case. It has the Texas Instruments logo on it. So I knew this had to be relatively old, and normally I'm not super interested in calculators, but when I took this out of the case, there was something about this one that piqued my interest. So go ahead and pull this out, and you can see this is a very old calculator. This is a Texas Instruments SR-50, and it is from 1974. And the reason that I was interested in this thing after taking a look at it was the type of display that it uses. It's not a standard LCD like you would see on modern calculators or even a lot of older ones. This calculator uses tiny little red LEDs to produce numbers, and it's not just like a simple 7-segment display. It's actually quite a bit more involved. So here's an up-close look at this calculator. You can see it is in extremely good shape. It doesn't look like this thing got a lot of use at all. And if you take a look closely at the display, you can see it's not just your standard 7-segment display. It's got little housings for a bunch of little tiny LEDs inside each of one of those little circular things. And the first time I saw that, I was like, I want to see this thing fire up. I want to see what those look like. And this calculator was only $5 at the thrift store, so I figured, you know what? Well, I'll buy it. I'm going to take it home. Let's see if this thing works and see what we can do to make it work if it doesn't. So I got it home and took a look at it some more and did some more research and figured out these calculators use nickel-cadmium batteries. And so to remove the battery pack that's in here, you have to stick a plastic tool inside this little groove here and pry the clip loose, and so that will remove the battery pack. And if we take a look at it, this is the Texas Instruments battery pack BP-1, and it's leaked a little bit. You can see there's some battery corrosion around the edges of the cells. And the way this battery pack works is kind of strange. It has these two terminals right here in the kind of the middle of the battery pack area, and those make contact with two metal terminals on the pack. So once this goes in here, it will be making contact with these two terminals, and that will provide you with your power. And of course, after seeing the battery pack leaked like that, I knew full well that it wasn't going to turn on because the batteries are obviously long dead. If I go ahead and flip the power switch, you can see we have no life out of the display. So those batteries are completely dead. But after doing some more research, I figured out that the cells that are in this pack are just standard AA rechargeable nickel-cadmium batteries. So it'd be really easy to take these old cells out and rebuild the battery pack with just some modern nickel-cadmium batteries. And it's actually very important that this battery pack is working due to the way that this calculator charges the batteries. On the back of the calculator, we have a little jack right here for the charger, and all the charger is just an AC transformer, and it's an 8-volt AC output, and these batteries are only 3.6 volts. This pack is 3.6 volts, and you're probably wondering, why are they using 8 volts AC to charge a 3.6 volt battery pack? Well, this battery pack also serves as a voltage regulator. So if you were to plug in the charger, the 8 volt AC charger, into this calculator without the battery pack, it could damage the LEDs and it could damage the ICs on its board because it's using these cells to regulate that voltage down into something that the calculator can handle, and it will also charge these up. So what I decided to do to actually test the calculator and see if it's working is hook my bench power supply up to it and inject 4 volts into it, because when you charge one of these NiCad packs, it'll kind of go up to around 4.2 volts when it's fully charged. So I figured 4 volts would be a safe bet. And I was able to figure out that this terminal right here is the positive terminal. So if I go ahead and turn on my bench power supply, and I have it set to 4 volts, so I'm going to go ahead and hook the clips onto the terminals. So just like that, and if I go ahead and turn this over, it's going to be kind of at an odd angle, but if I go ahead and turn it on, you can see it came to life. And that is what one of those LEDs looks like when it is on. It has very thin segments. And if I go ahead and put all 8s in, you can see they all work just fine. So the LEDs in this calculator are still working. And if we go ahead and type an equation, let's say 56 times 25, you can see it still does math correctly. So all of the logic inside the calculator is still working perfectly fine. And when I was researching this specific calculator, the SR-50, I found out this is a pretty notable calculator because it was Texas Instruments' first scientific calculator that could do logarithms and trigonometry. And you can see by the buttons on this thing, we have sine, cosine, and tangent. And we also have an arc button, so it must be able to do arc sine, arc cosine, and arc tangent. So that's pretty powerful for a calculator from 1974. And you can see here we have the natural log, we have standard log, we have factorial, which is pretty cool. We have reciprocals, so we have 1 over a number that you put in, square roots, and exponents. So this is a pretty full-featured calculator. And it looks like we also have summation. I wonder how that works. I haven't read the manual for this one, so I'll have to figure out how that works. So this is a pretty advanced calculator. It's not just your basic calculator that you pull out of a drawer that just does, you know, addition, multiplication, division, and subtraction. It's got quite a few nice features. And as far as I know, everything's working fine. Like if I do 9 and then x squared, I should get 81, and I do get 81. So it's still able to do math. Let's see if I remember my trig. If I do 90 and then I do cosine, I get 0 because cosine is the x-axis. And if I were to do 90 sine, I should get 1 because that is the y-axis. So if I do sine, I get 1. So it's able to do trig functions. It can also do pi. If I hit the pi button, that's how much it can estimate the value of pi. And one feature I thought was cool about this calculator is it has an interesting way to handle overflows. So if I type in all 9s and then I add 1, instead of giving an error, look at what it does. It says 1 and then it puts a 10 over on the edge. So I guess it's 10 more zeros after the 1. Let me see how many digits. 2, 3, 4, 6, 7, 8, 10. So it's got 10 digits for the regular number. And so if I add 1 and 10, so I guess that means 10 zeros after the 1. And it will keep doing that too. So I don't have to just add 1. I can say, I can do all 9s and say times 5. Now it has 5 plus 10 zeros after it. I don't think it can round more than just saying there's this many more zeros after it, so it's just kind of approximating it, but it's cool to see that it doesn't just show like error, it actually attempts to do the math, but it does have an overflow at some point. So like if I do all 9s and then multiply it by all 9s, let's see what it does. Oh wow, it can actually handle that. That's amazing. So that's the regular number. And then if I can read upside down, that's 19 numbers after that. So it actually kind of can give you a loose approximation of what your answer might be. And it does have negative number support as well. So if I do 0 minus 1, it does have a negative sign at the very end. So it can do negative numbers. But this does have an overflow. That's what it does when it overflows. It shows all 9s plus 9, and then it flashes the display. So That's what it does when you've overflowed the memory and it can't display anything more. So it will kind of give you an indication that you've done that. So I thought that was kind of a nice way to show that. This other switch over here is for radians or degrees, like a modern Texas Instruments calculator. So if you want to view your trig answers in either radians or degrees, you can do that with this calculator. And I did also want to note the current draw on this thing. So when it's on and showing a single zero, it's drawing 67 milliamps. But if I go ahead and put all 8s on the screen, now it's drawing 114 milliamps. So it does draw more current when you have more of the LED displays turned on. So there's the SR-50. You can see it's working fine. I just need to rebuild this battery pack with new cells, and then it will be able to run off battery power once again. But that's going to be a little bit of a job because these batteries are spot welded together. So I'm going to have to rip apart this battery pack. I might have to cut off the little pieces of plastic here so I can get the cells out. And I do have a spot welder, so I'm going to try to spot weld some nickel cadmium cells together and rebuild this battery pack. And in doing that, I'm also going to make some new tabs for the pack because this one's all corroded and it's probably not going to make that good of a connection. So we'll get that done. I just wanted to show these calculators off first. So what's the story with the second calculator? Why do I have two of them? Well, I wanted to find the factory charger for this calculator, and I was able to figure out what model number it was. And I was searching on eBay, and nobody had just the charger for this calculator. There was one that had just sold not too long ago, but I ended up being a little bit too late for that. So my only option was to buy another vintage calculator that used the same exact charger. And so that is where this comes into play. This is a Texas Instruments SR-11. This is a year older than the SR-50. It was made in 1973, and this is a complete in-box example of a SR-11. It comes with the charger, the manuals, and the calculator. So let's go ahead and take a look at this one. Might as well go ahead and take a look at the box first, because I imagine not many of these are still out there. That's what the side of the box looks like. You can see we have the profile of the calculator. A time-saving quality electronic calculator from Texas Instruments. And there's the top of the box. It shows the contents of what's in it, the calculator, the carrying case, and the AC adapter. We'll go ahead and open this up. There's our carrying case for the SR-11. It's a little bit different than the SR-50. This one has the Texas Instruments logo kind of embossed into it. And this one, it's kind of just painted on or silk screened on, and it's kind of worn off a little bit. Here's our charger. This is the main reason why I bought this calculator, because it came with this. So I'm able to charge both the SR-50 and the SR-11 because they both use the same charger. Here we have the manuals. This first one, this little sheet of paper, is the Texas Instruments Consumer Service Facilities. So there's all that information. And here's the actual manual for the calculator itself, the SR-11 manual. Goes over all of the features this calculator does, and I kind of glanced through it already, and it actually goes pretty in depth. This is a more basic calculator, but I was pretty surprised when reading this how complicated it actually gets. Like, we have all these complex equations in here. You wouldn't expect that from a consumer grade calculator from the 70s, would you? And I thought this was interesting. On the back, we have the warranty registration, purchase date, received October 21st, 1974. So that is when this calculator was first set up and used. And there's the calculator right there. Let's go ahead and pull it out and take a look. So here's our SR-11. This one's in a little bit worse shape. You can tell it's been used because the silver paint around the little trim here has worn off. This one's a little more basic. It doesn't have trigonometry, but it does have reciprocals, exponents, and square roots, as well as pi. So that is the feature set of this one. This calculator also uses the same little LED displays that the SR-50 used, so it's going to look just as cool when we power that one up. If we go ahead and turn this one around, You can see this one's a little bit different. We don't have a battery pack that is user accessible. You have to take out the 2 screws right here to open the calculator up, and that will give you access to the batteries. But when I first saw this calculator and I looked at the charge port on the back, you can see it's got a lot of oxidation on it. Well, that can only mean one thing. The internal batteries have leaked on this one as well. You can see we have the same 3 cells right here, the 3 1.2 volt nickel cadmium cells, but this one, they're not spot welded together in a pack. They're actually user replaceable. You can see how this one's moving. I can just pull these out, and I think I'm going to be able to restore those battery terminals. They got a lot of blue and green gunk on them from the battery corrosion, but once I remove these, I'll go ahead and soak those in some vinegar or alcohol, and I'll get as much of that crustiness off as I can. And if we take a look inside the calculator, it actually details the specs of these battery cells. They are 450 milliamp hour nickel cadmium rechargeable batteries, and they are fast charge batteries. It says, do not attempt to use charger when substitute batteries are used, because this calculator works the same way as the other one. The batteries serve as a kind of voltage regulator when you plug the charger in. And looking at the other side of the calculator, the side where the logic board is, I don't see any damage at all. I don't think the battery corrosion has gotten that far. So it looks like the board is pretty nice. I do see a little bit of crustiness down here where this wire is, so I'll have to clean that up. But the rest of the board looks great. All the components look fine. Nothing looks damaged. But I did see some little crusty crumbs kind of just floating around in there, so I'm going to have to take the board out and just clean all that out. But overall, not bad first impressions. The battery leakage didn't go very far. It didn't get all over the board, so I think we'll be able to get this calculator working as well. And this is actually the one we're going to work on first, because I can just take these cells right out, clean up the terminals, and put new NiCad cells in, and it should be able to run off of its own power. So this is the one we're going to deal with first. Oh, and I also found some little pieces of paper inside the box that I didn't see before. We have, make certain that switch is set to correct line voltage before use. That would be a pretty good idea, because on the charger, there is a switch for 115 volts and 230. And if you're looking for the correct charger for one of these calculators, either one, it is the Texas Instruments model AC9200, and it is rated for 8 volts AC output, 100 milliamps current limit. And the output jack is just a regular 2.5 millimeter headphone jack style connector. And so that will fit into the connector here for those calculators. And the other piece of paper here just kind of tells you that the batteries were fully charged out of the factory, and you might need to plug them in to charge them first. Don't use the charger unless the batteries are installed. All of that information that you need to know. So it's nice that those are still there. I imagine those get lost pretty often. And so here are the 2 calculators that we are going to be repairing in this video, the SR-11 and the SR-50. And it is nice that they both come with their carrying cases. You can see a little bit different. They're not exactly the same thing. The zipper is different. The spacing between the zipper, I don't know what you call these, the parts that zip together. The spacing is completely different, so not the same zipper, not the same case, but it's nice to have both of those. But the one we're going to be working on first is the SR-11, because I think that is going to be the easier one to get fully restored. So let's get started. So first things first, let's remove the old batteries and assess the damage. So the main battle we'll have to face here is getting these out, because there's quite a bit of corrosion on those terminals. So let's see what I can do here. This one is free. I already knew that, so I should be able to do this one. That one is not free. Oh, it is now. Okay, so that one should come out. This one, yep, and that should come out as well. Ooh, we have a date code. I don't know if you can see it, but it says 7427. So these batteries are from the 27th week of 1974. So They have never been replaced before. And if I look at the date codes on the chips, this one is 7421, 7423, 7423. So this calculator was made in around mid-1974. So this is a little bit of a later SR-11. There's one. The batteries themselves actually don't look horrible. So good thing we're pulling them out now. There we go. All the original cells are now out, and you can see there's quite a bit of corrosion and battery acid in that area. And of course, there's a piece of paper right under those batteries that shows the direction of the cells. So hopefully I can save that, because with all that battery corrosion there, it is pretty hard to read, and I don't think I can save it because I'm kind of putting my spudger up against it, and I think it's just crumbling to pieces, unfortunately. But this is actually pretty easy to figure out, because right here where this wire connects from this battery terminal, there's a plus sign on the circuit board, and this one obviously is going to be the negative. And we can see that the positive wire is connected here, so that means this is our positive and this is the negative for this battery. I can see that these two terminals are connected together, and so are these two. So how this is set up is positive, negative, positive, negative, positive, negative. And looking at the piece of paper, that's what it does say. I'm gonna go ahead and remove this piece of paper, and I'll probably stick in a couple labels or something in there just so I know in the future. But there's our original 3 cells. 2 of them have 27th week of 74, and one of them has 24th week of 74. So these are all original cells, all completely dead and leaky. They are going in the garbage. And so that is what we're starting with. So I went ahead and I made a baking soda and water solution. And I'm going to try to dissolve as much of this as I can. But the paper, though, is completely gone. So I'm just going to rip this out of it, and I will make sure to write or put a label for the positive and negatives. You know, I wonder if these terminals come out. There we go. That'll make that a lot easier to clean. Disgusting. Okay, yeah, that'll help me immensely in getting the rest of this area cleaned up. And you know what I think I'm going to do? I think I'm just going to replace this label. I'm going to print a new one that looks very similar to that one, and I'll put it in there because I'm going to end up damaging this part of the sticker that's got corrosion all over it. It's just degrading to pieces. So I'll go ahead and do that when we're done servicing this thing. Well, a little bit later, and here's where we're at. I managed to get both of the corroded labels out of this thing, and you can see silk screened in the calculator, they have part of that warning message. I don't know why they would do that. I don't know why they wouldn't put the entire message there, but that is something they did. I got about 95% of the corrosion out of this thing. You can see it's looking a lot better. I went ahead and soaked these 2 terminals in some baking soda and water for a good while. I still have to get the bigger pieces off, and I can just get that with a screwdriver like what I'm doing with this one. You can see I'm able to get some more of that corrosive material off. And as far as this part of the calculator is concerned, I think I'm just going to leave the board in it for now because I don't want to risk damaging these LEDs, because good luck trying to find replacements for that. So what I'll do for now is I'll just kind of vacuum around the edges to get some of those little crumbs out of there, and then I'll continue working here, and then we'll be able to put some new batteries in it. All right, and here's what everything looks like after it's been fully cleaned up. You can see the inside of the calculator is looking really nice now. as well as the part where the circuit boards are. I gave that a good dusting, so now that's all nice and clean. Those are what those two battery terminals look like. I didn't think they would come out looking this good. I thought there would be a lot more damage, but the corrosion didn't affect them too terribly. This one is the worst out of all of them, and there's still a little bit of crust on it that I wasn't able to get off, but it's way better than what it was before, and it should still make a connection. If not, then I can file it down. And this one here is also looking pretty good. It's really not that bad. And I cleaned up the charging jack a little bit. You can see that's looking quite a bit better. A lot less corrosion than what it had before. I might have to squirt some contact cleaner in there because the inside does have oxidation as well, but it's way better than what it was. I should be able to get it to work. But before I put this thing back together, I want to replace the two labels that were here and there. And so what I did is, before ripping apart those labels, I took a picture of both of them so that I could recreate them as best as I could. And these are what I came up with. I tried to be as true to the originals as I possibly could. And so I made a new battery polarity label, as well as a pretty much one-to-one recreation of the battery warning label. I made sure to make the spacing exactly the same as the original, and I italicized the same words that were italicized on the original label. And these are both on sticky paper, so I will be able to just stick them right in. All right, moment of truth. With 3 new NiCad batteries installed and the calculator back together, let's see if it works. It does. Look at that. We have a 0. Let's fill the screen with 8s and just see if all the LEDs are working. Looks like they are. This one we only get 8 digits for the regular number. And so if I add 2, it's able to do the math. So this calculator is working. Let's do the square root of 9. 3. Let's do 20 squared. 400. This calculator kind of shows the contents of memory as it's doing the calculation. I'm going to do that again. You can even see what I'm typing. Some of the LEDs are flickering a little bit. That is normal. As you can see, it's able to come up with the correct calculation. And there's pi. 5 minus 6. -1. The negative sign is working. 5 divided by 2. Yep, that is correct. Let's see how this calculator handles overflows. I'm going to type all 9s, add 1. It does the same thing. 1 plus 8 digits after the 1. So the SR-11 is now fully working. It just needs a little bit of an exterior clean, and then it will be fully operational again. But one thing I want to do real quick is test to see whether the charger can actually charge these new NiCad cells that I put in. So measuring across the 3 batteries in series, we get 3.7 volts. And the way to figure out if the charger is doing its job is the voltage across the batteries will increase a little bit when I plug in the charger. Well, we're not out of the woods yet. When I hooked up the charger to the rear jack on the calculator, the voltage across the batteries did not rise. And so to test the charger to see if that was the problem, I went ahead and hooked it up to my digital voltmeter, and it is outputting 9.5 volts AC. So the charger is working fine. So there's a couple things I want to test now. Are we getting AC voltage at the charging jack? And is this diode still working? So let's go ahead and test those things. With the meter across the diode, we're getting 0.6 volts. And I also went ahead and put the leads the other way and we got nothing. So the diode is good. And with the meter across the charging jack, with the charger plugged in, we're not getting enough voltage. And if I go ahead and wiggle the charge cable around, it shifts quite a lot. So the problem that we're facing here is just that the jack is so oxidized, it's not letting enough voltage get through. So I need to clean out the inside of that socket, and then the calculator will be able to charge. All right, so now after filing the inside of that socket a little bit and putting a bunch of contact cleaner through it, I am now getting 7 volts across the charging jack. And if I move the charger around, you can see it is very stable. So obviously the calculator is loading the charger down, and so it's only outputting 7 volts instead of 8, but that should be enough to actually go ahead and charge the batteries. And it sure is. After going across the battery pack, we now have almost 4 volts at those batteries. So now you can see the charging voltage has gone up. So now the calculator is charging. So that was the only problem I needed to fix. I went ahead and put a little label just in the back there so I knew when I replaced these batteries. So now this calculator is fully working and it can actually be charged again. All right, I've gone ahead and cleaned up the SR-11 as best I could, and it is looking really good besides the part of the silver paint that's worn off a little bit. So you can see it is in very nice shape. So that is the SR-11 completely fixed. Let's move on to the SR-50. So as for the SR-50, we already know that it works. We just need to make a new battery pack for it, and then it will be able to operate off of its own power. And because the SR-50 uses a battery pack, it's going to be a little bit harder to make a new battery for this one because these cells are spot welded together. And it seems like the only way to get them out of there is by cutting off these little pieces of plastic that go between the sides of the pack, because I can't just pull the cells out. I'm going to have to pull out the whole thing. So I'm going to have to use some cutters and just snip these plastic pieces off, and then I can pull out the cells. And in making a new battery pack, I'm going to replace the sticker. So I'm just going to rip off that one like I did on the SR-11. And so I'm just trying to see the best way to do this because I don't know how deep these plastic bits are. So I'm going to have to cut one side and see maybe I can just pull it up a little bit. Because my goal here is to reuse this same battery pack housing so I can keep it all original looking. But if that doesn't end up working, then I do have a plan B. Oh, it was already kind of broken. Look at that. It's pulling up already. Because as long as it's like this, I can get past that. So this should be pretty simple. This is something you'd never want to do with batteries that you know are charged. Because if you puncture one, it could mean disaster. But these batteries are long dead, so nothing's going to happen. Okay, I'm getting somewhere here. There we go. Now if I can just pull these out of here, that would be great. There we go. Okay, there is that mess out of there. So I will be able to reuse this battery pack shell. You can see all the crust that's in there. So those batteries are long gone. But I'm not going to throw those away just yet because I want to see how they spot welded them, because I am going to spot weld a new battery pack that looks just like that. So I'm going to go ahead and clean all the corrosion out of this thing, and then I'm going to get my spot welder set up and I'll show you what I'm going to do. All right, so here's what we're going to do. I 3D printed a little AA battery holder that I can use to hold the 3 new NiCad cells. And if I put the old battery pack on top of them, I can see the width is exactly the same. So if I spot weld these 3 batteries exactly like this, it's going to fit perfectly inside that battery pack housing. And so how this is going to work is I have my battery powered spot welder here, and I'm going to be using these thin nickel strips to go across two of the cells and weld them together. And so on the old battery pack, I've determined that this connection here is the positive. So the old battery pack is the same as these three cells in there, just like that. So I need to put a strip going from the middle cell to the right cell. So I'm going to cut out a little piece of the nickel strip here so I can get it exactly the length that I want it. So that should be fine. I rounded off the edges just a little bit. So what I'll do here, just so I can get a good solid weld, is I'm going to tape one of the sides down just so it doesn't move around when I'm trying to make a weld onto it. Okay, apparently the battery inside the spot welder is screwed up. I'll have to spot weld a battery for the spot welder. 3, 2, 1. Okay, and just to make sure that that actually welded, I'm just gonna try to pry on it with a screwdriver. Oh yeah, that's a good solid connection. So it's just that tiny little click, and it made a perfect connection to the top of that battery. So now I can take the tape off so I can do the other side. I'm going to do a couple welds on the negative side of this just so I know it's a good connection because I have the space to actually do that. So first we'll do a weld right here. Okay. And we'll do another one right here. You can see it does spark a little bit, so you do have to be a little careful, but there we go. That's 2 welds on the negative side of that one, and that is solid. So there's a connection between the negative of that cell and the positive of this one. All right, so right now I have the old pack and the new pack mirrored, and so the strip that I just welded was between the negative of this cell and the positive of this one. So now I need to go from here to here, and so that's going to be the negative of this cell to the positive of that one. And it's going to be the same drill as before. So I cut out a new strip and I rounded off the corners a little bit. Go ahead and tape it down. Ooh, that one kind of sparked at me a little bit. I'm going to do one more on this one just to make sure that it's okay. Okay. I trust that more now. And so now comes the harder part. I have to shape one of these nickel strips so that it'll go from the battery and make a terminal connection like that. So I'm going to have to recreate the both of those. So one's going to connect here and the other one is going to connect here. All right, I think I have one. So I'm going to weld that on there. Oh, crap. That didn't go. Shoot. All right, well, it ain't super pretty, but it should work. Okay, that should be it. I'm just going to go ahead and put some Kapton tape around this thing so that everything is held in place. Well, there's the replacement for the old one, all welded together and looking nice. Let's put it back in the housing and see if it works. And of course, one of the welds had to come off, so I'm going to have to get that back on. All right, there's the new battery pack put back in the original housing. And I was able to make 2 terminals right there in the middle, and those should meet on the calculator. I put a voltmeter across them, and I get 3.7 volts. So let's see if it works. Okay. Let's see. Ooh, we must not be making a contact. Oh, there we go. Hey, look at that. New battery pack, and this calculator is now running off batteries. There we go. The SR-50 is now fully restored. And so that is the Texas Instruments Calculator Restoration Series. The SR-11 and the SR-50 are now completely restored. And I want to show you something cool about the SR-11 that the SR-50 doesn't have. When it shows a number that is more than 1 digit long, after about 15 seconds or so, as a power saving measure, it will automatically turn off all the digits except for the last number. See, it just did that. And so if you press any button, it'll wake it back up. But what the manual says to do is push the positive or negative sign twice. So pushing it once makes it go negative, and pushing it twice makes it go back to what you had. And that's just so you don't have to put in any operators. You can just hit the button twice and you're right back to where you were. And here is the SR-50 battery pack all finished. I went ahead and put a new label on it, just like the old one, but I added a little note in the corner that said when I rebuilt it, so that I will know for the future. So with that, the SR-50 and SR-11 are now completely restored. And so that is the restoration of the Texas Instruments SR-50 and SR-11 calculators from the early 1970s. This was a little bit of a different project for me, but if I do end up finding some vintage calculators like this again, then maybe I'll do another video about them. So, thanks for watching, and I will see you in my next video.